Hi everyone, in this video we would be designing the Splitwise application, which is generally asked in most of the top product based companies. So let's get started. Now let's understand the system. So in order to understand this, I have created 3 different accounts and these are the names of each of those accounts. So initially I have logged in into Jai's account. Okay. So whenever you would be creating a new account, your interface would be empty, completely empty. So first of all, if you want to create a group, you have to click on this button, which will help you to create a group, right? You would give the name of the group and the members of that group. Okay. And this is the by default group, which would be present into all of our accounts. So initially it won't be visible to you, but whenever you add some friends using this option, this group will automatically become visible to you. So all the one-to-one expenses would be stored into this non-group expenses, and all the group expenses would be stored into the groups which are made by us using this option. Okay. I hope you understood this part. So even one-to-one expenses are stored in one default group, right? Now, when I click on this Goa trip group, this is how the interface would look like. And you can keep on adding different members into this group using this particular option. So let's say Jai added me into this group. Okay. And we both went for the Goa trip using the flight. So I was the one who paid $120 for the flight, right? And we splitted that bill equally. So it means that $60 would be my charge and $60 would be charge of Jai. So basically in the Jai's account, it is showing that you have borrowed $60, right? So till now, everything is understandable. Now we also add Parth into this group, and what Parth will see is Parth will be able to see the expense which is over here, and he will also see that he was not involved in this expense because obviously the participants of this flight were Shubh, that is me, and Jai. Okay, Parth was not there, that's why not involved is written over here. Now we all the friends, that is Parth, Jai and me, went for the cycling. So the total charge for the cycling was $18. It means that 18 divided by 3 is 6. So 6 belongs to Parth and rest 12 will be paid by me and Jai, right? So one thing to observe over here is instead of this thing, there should be 2 lines written. The first one would be Shubh owes you $6, Jai owes you $6. But instead of that, how come this is written over here? How come my name is not there? My name is not there because we are currently using this particular feature. The name of this feature is simplified debt. So what this feature will do is it will basically reduce the number of transactions. So let's try to understand this with the help of graph. So currently in that group, Jai is going to pay $60 to me because of the flight, and Jai and me both will be paying $6 to Parth because of the cycling. So this will happen if this simplified debt feature is turned off. But when we turn on this feature, then the number of transaction into this graph would be minimized. So we would remove this edge and Jai will be paying $12 over here. And instead of 60, Jai will be paying me $54. So that will happen because of the simplifying feature. So over here, you can clearly see that in the Jai's account, it is written that you owe Shubh $54 and you owe Parth $12, which is what we saw just now. So this simplified debt function will be minimizing the number of transactions. So I hope you understood this group related features. Now coming to the one-to-one expenses. So again, for that, what you have to do is You would just select a particular user with whom you want to create the expense. For example, Jai wants to create the expense with me. So Jai will click on my name and create the expense. So the name of the expense is dinner and the total amount is $20 and it is being paid by Jai. So here you can select by whom it was paid and how you are willing to split that bill. So currently we have decided to split that bill equally. So if you click on this option, you would be getting various options, right? So this is one-to-one expense, which is added into the non-group expenses. Okay. So here you can see that I am the one who is owing Jai $10. Okay. Similarly, Jai can create multiple expenses. For example, the second expense is ice cream. So this expense was paid by me and the total amount was $10. Basically, Jai would be paying me $5, isn't it? So in the Jai's account, here you can see the red message which says that you borrowed $5. And earlier, Jai lent me $10. So if we try to cancel each other, the total would be $5 would be paid by me. So here you can clearly see that Shubh is owing Jai $5, right? And here we won't be having that simplified debt functionality because it might be the case that Shubh does not know the path, right? So the total simplification would not be done in this particular group like we did over here. Here all the three people would be knowing each other, but here everyone will not know each other. That's why the simplification will be only done between the two users. That is 10 minus 5 would be 5. So only that simplification would be done. The total simplification would not be done. So I hope now you understood the group related features and one-to-one related features. So now let's check out the requirements which we can come up in the interview. These are the requirements and I have categorized the requirements into two categories. The first one is dynamic, where the users or admins would have different functionalities. And the second one is extensible. So in the dynamic categories, you can discuss these requirements with the interviewer. The first point is that we should be able to create the groups, right? And once that group is created, we can also add the users into that group. And each and every user can create the expense. Now that expense can be a group expense or it can be a one-to-one expense. Okay. And finally, the users should be able to view their balance sheet for each group. Now let's try to understand what exactly this balance sheet is. So I've taken this example wherein there is a group called as Goa trip and these are the members into that group. And till now in this group, there are two expenses which are created. The first one is dinner, wherein I paid the bill of $40 and the participants were this. The second one is cycling, and again I was the one who paid for cycling and the amount was $20 and the total participants were this. Okay. So my balance sheet in this group would look something like this. That is, the total amount paid by me since this group was created is $60. 40 plus 20 is 60. But out of that, the total expense was $23.3. It means that this is what I should have paid for myself, but I have paid extra. Now all those extra balances are stored into this balance hash map, wherein the key would be the user and the value would be the amount, and this amount can be positive or negative. Okay, because this is positive, it means that I will be getting, that is Shubh would be getting this $23. If it was negative, then Shubh would be paying Bob $23. So this is the balance sheet and these are the three attributes which would be present into that balance sheet. So that is what I have written over here. So user should be able to view their balance sheet for each group. Now this balance sheet would be different for different group. Okay. And interviewer says that you should also implement this particular feature, right? So we will do that. And as we know, each and every user can create the expense, right? So while creating that expense, the user can also select different splitting criterias like equal, percentage, or unequal, etc. And we can add more and more criterias in future. So basically we have to make this system extensible, right? So I hope you understood the requirements properly. Now let's check out the entities and the entire flow with the help of class diagram. So this is the entire class diagram of our splitwise application. So in order to understand the flow of this system, let's check out each and every classes first. So let's start with the models. So we have one class called as group. Each group would be having this attributes like ID, name, members, expenses which are added by the members, and each and every user would be having their own balance sheet. Okay, so there is one has a relationship between group and the balance sheet, and each balance sheet would be having these attributes, and I've already explained the balance sheet earlier. So I hope you are understanding what are these attributes, and each group would be having list of users, right? So again, there is one has a relationship between group and the user. So user would be having ID and the name. Similarly, group would be having list of expenses. So again, there is one has a relationship between group and the expense, and each and every expense object would be having these attributes like description. So in description, you can add why have you created this expense. For example, if you are going for a lunch with your friends, then you can say we went for lunch. Then the amount of this particular activity will be present in this attribute, and who has paid that amount will be present in this attribute. And I also have list of split. So earlier I thought of adding list of users as a participants. Okay, so each activity will be having participants, but what I thought was it is just giving me list of users. Instead we can have one additional information if we have list of split, because each and every split will be having the participant who has participated into this expense plus the amount which this user is going to pay, right? So I discarded the plan of using the list of participants or list of users and went with list of split. Okay, and this expense class will also have the split type like equal, percentage, etc. Now if the client who is creating this expense chooses equal split type, so in that case all the participants would be having equal amount. But if the client chooses percentage, then obviously the amount of each and every participant would be different. It would be based on the percentage that the client has chosen. Okay. Now this groups, which you can see over here, would be stored into the HashMap, or you can say in-memory database. And in order to perform CRUD operation on that in-memory database, I have created group repository. So you can see the functions like find by ID, save, delete, etc. So all those functions would be present into the group repository, and they would be performing CRUD operations on this in-memory database, right? And all the business logic related to group would be lying into this group service. So you can see functions like create group, add the member, add the expense, simplify that, etc. Okay. Now, in order to perform the simplification det functionality, I have created one separate class where the logic of that function would be lying. Right. So if the user wants to perform simplification of the det, then obviously user would be interacting with the group service, and group service will interact with the det simplification service and get the simplified output. And whenever user wants to add the expense, at that time again user will interact with the group service and call this function called as add expense. Now group service will in turn call the expense service and pass all those informations like group ID, the description of the expense, the amount and by whom that amount was paid, and the list of participants who had participated into that activity, and the split type. Okay, so on this parameters we would be creating the expense. So in order to create the expense, if you remember, each and every expense object would be having list of split, and that list of split is dependent on the split type. So on the basis of split type, what I'm doing is I am creating the split strategy. So I am using strategy design pattern for splitting the bill. So there is one split strategy interface which has a function called a split, and I want to split this amount among these participants, and I will also pass some metadatas, right? So equal split strategy will split this amount among these participants equally, whereas percentage split strategy will be splitting this amount among these participants based on the percentage. Now those percentage would be sent via this metadata. Okay, and the output of both of this function is nothing but the list of split. So this list of split would be used in order to create the expense object. Okay, and by the way, I am using factory design pattern over here in order to create this objects. If user selected equal, then I would create the equal split strategy object. If user selected percentage, then I would create percentage split strategy object, and so on and so forth. Okay, so strategy design pattern will allow me to add more and more algorithms, keeping the interface intact, whereas factory design pattern will allow me to create the strategy objects at runtime based on the user input. All right. And once I create the expense object, the balance sheet of all the users in that group would be updated, isn't it? Because there is new expense which was added to the group. So all the logic related to updating the balance sheet would lie into this particular class. All right. So we have gone through each and every classes. Now let's try to understand the entire flow. So this is the client which would be interacting with the group service. So if the client wants to create the group, then client will interact with the group service, and this service would create the group object, and it would save that object to the in-memory database with the help of group repo. Okay. And if the client wants to add the member, so again it will directly interact with the group service in order to add the member. If the client wants to perform the simplification of the debt, so in that case client will interact with the group service, and group service will interact with the debt simplification service. If the client decides to add the expense into a specific group, so again it will interact with the group service, and group service will interact with the expense service, and expense service will interact with the factory to create one of the objects based on the user input. Once that object is created, we would be able to create the expense object, and once expense object is created, we will be updating the balance sheet of all the users with the help of balance sheet service. Okay, so I hope you now have clear understanding of about the entire flow of this application. So now let's check out the output. This is the client class. So over here we have created 4 different users, and we also have created some objects. So the first one is in-memory group repository. So over here we would be having CRUD operations which would be performed on in-memory database. Okay, and we also have some services like balance sheet service, expense service, simplification service, right? Now all these services are not user facing. User facing service is the group service. So user will just interact with the group service. So firstly, user decides to create a group using this group service, and the name of that group is Goa trip, and these are the list of members of that group. Okay. Now I have created couple of expenses into this group. The first one is lunch day one, and the bill amount was $100, and Shub was the one who has paid that bill. And total number of participants are this, and they have decided to split the bill equally. Similarly, for the lunch day two, the bill amount was again $100, and Bob was the one who paid that bill, and the list of participants were Bob and the Tom, right? And then we are simplifying the debt and printing the balances. So let's do one thing. Let's comment this stuff and check out the output. So as you can see, initially I was the one who has paid the bill for the lunch day one, right? So that's why $100 is mentioned in this paid, and the expense is $50 because 50 is what I should have actually paid, and another 50 will be paid by the Bob. So here it is showing that Bob will pay me $50. Okay. Similarly, on the day two, Bob paid $100 for the lunch, and the actual expense of Bob was $50 on the day two. Okay, it was $50 on the day two, but on the day one it was $50. So actual expense of Bob is $100 till now since the group was created. And here it is clearly mentioned that Bob will be getting $50 from Tom, and Bob has to give $50 to me. Okay. And in the Tom's balance sheet, total amount paid by the Tom is shown 0 because Tom has never paid anything till now since the group was created. And the expense of Tom is $50 because of the lunch day 2. Okay. And Tom is basically going to give Bob $50 because of the lunch day 2. Okay. So this is how the balance sheet of all the users would be looking when we have not turned on simplification debt feature. Now, if I turn on this feature, let's see the output. So here you can see that the simplification process has been done. Earlier, Tom was going to pay $50 to Bob, and Bob was going to pay $50 to me. So instead of doing that, what we did is Tom is directly going to pay me $50. That's it. So we have reduced or minimized the number of transactions. So I hope now you understood the simplification debt feature. So now let's check out the code. So these are the classes which I have created. So let's see all of them one by one. Let's start with the enums. So in our application, we have the enum, which is split type. And in this enum, we would be having all the different types of split like equal, percentage, and let's say in future I want to add unequal as well, so I can add that. Okay. Now let's check out different models. Okay. So firstly, we would be having this user class. Each and every user would be having the name and the ID. Now coming to the group class. So in the group class, again, we would be having the name and the ID for the group as well. And each and every group would be having list of users. So I'm calling that as members. And each member can create the expense in that group, right? So group would be having list of expense as well. And every user in that group will have their own balance sheet. Okay, so let's see what is the balance sheet. So balance sheet has these three attributes. The first one is total paid. So this variable represents the total amount paid by a specific user since this group was created. Okay. and total expense will represent the total share of that user since this group was created, right? I have already explained all this attributes while explaining the requirements. And in my balance sheet, I would be having a map of other users and the amount which I would be taking or giving. So if it is positive, it means that I would be taking from this user. If it is negative, then I would be giving that amount to this user. Okay. And we also have the functions like add total paid and add total expense, which would be incrementing this variables. Apart from that, I can also add the balance of a particular user. So if someone makes an expense, so in that case, we would be updating this balance map. So it would be changing the amount between me and this user, right? And if it becomes 0, in that case, I would be removing that entry from the map, because then there is nothing between me and that user, because the amount has become 0, right? Similarly, I have this clear balances function which would clear this entire hash map. Okay, so I hope you understood this balance sheet. Now again, coming to the group class. So this group class has some CRUD functions like adding the member into the group, adding the expense into the group, and getting the balance sheet of a specific user, right? Now let's check out the expense class. So in the expense class, we would be having the description of that expense. So instead of description, you can also write the title. So for example, if all the friends are going for a lunch, then the description would be this is lunch or lunch. Then this is the total amount of that particular activity and the user who has paid that amount. Okay. And here we would be having the list of split. Okay, so each and every split would be having the participant who has participated into that activity and the share of that participant. Okay, and finally we would be also having this split type, like it could be either equal or percentage. So accordingly we would be getting this list of split. We'll see this when we'll be checking the strategy design pattern. So I hope you understood all the models. Now let's check out the group repository and in-memory group repository. So in order to achieve the dependency inversion principle, what I've done is I've created one group repository interface and I've declared all the functions over here. So we have all the CRUD functions like find by ID. So this will find a specific group based on the ID of that group, and save function would be saving that group into the database. So this is one of the implementation of the group repository. The name of this class is in-memory group repository because this CRUD operations would be performed on in-memory database, which is the HashMap. Similarly, in future, if you want to add one more repository, let's say SQL group repository, then you can add that. And you can make it implement group repository, right? This follows the dependency inversion principle and it would be helpful to you because when you would be writing the group service, there you would be having the reference to the group repository. Now let's say if you didn't create that interface, then here you would have written something like in-memory group repository. So in that case, if in future you decide to move from in-memory database to SQL database, you would have to come over here and write something like SQL group repository, right? And it means that you would be modifying this class. So that is clear violation of the solid principle. So that's the reason why I created that group repository interface, right? So apart from the group repository, we also have access to the expense service and debt simplification service. So in this service class, we have these four main functions. The first one is to create the group. So in order to create the group, we would first create the object of the group and put all those members into that group, right? And then we would be using the CRUD function of the repository layer to save that group into the in-memory database, right? And finally, we'll return the ID. Now, in order to add the member in the group, we would be first fetching the group from the in-memory database. So the function for fetching is like this. So here I'm fetching the group from the in-memory database using this CRUD operation. And if it is null, in that case, I am throwing group not found exception. Okay. So once I get that group, I am just adding the member into that group. Now, in order to add the expense in a group, instead of having that logic over here, I have used the expense service for doing that job for me. So I will just call the expense service add function. Okay, so this function would be present into the expense service, which is responsible for adding the expense. We'll see this in a moment. And same thing will happen with the simplification debt. So over here also, if I want to simplify the debt in a specific group, then I would be passing the group ID as the input and delegate that logic of simplification into this simplifier object, or you can say the debt simplification service, right? So I hope you understood the group service, group repository, and the interface. Now let's check other services as well. So one of the service was expense service and another is balance sheet service. So in expense service, we have a function called add expense, which will be creating the expense and updating the balance sheet. So in order to create the expense, we need list of splits. Why? Because in the expense object, there is one attribute which is nothing but list of split, right? So in order to get list of split, we need the object of strategy, right? And this strategy object would be decided by the user. So user will be providing the splitting criteria. And if user has, let's say, selected equal split criteria, so in that case, I am telling my factory to create the object of equal split. So once I get the strategy of equal split, I am just calling the split function of the strategy object, and accordingly my strategy will be dividing that amount and returning the list of splits. And this list of splits would be used into creating this expense object. Okay, and finally this expense object would be added into the group. Once I add an expense into the group, I need to update the balance sheet of all the users who are present into that group, right? So that logic is present into the balance sheet service. So let's check out that. So if you remember, in a balance sheet, we have three attributes: total paid, total expense, and the balances. So what I'm doing over here is I am incrementing the total amount paid by this user. So for that, I am adding all the amounts which are present in this list of split. Okay. So in this split, all the users would be there with their share of the total amount. So I am adding all the shares, and this is the amount which would be added into the balance sheet of this user, right? So I'm doing that. Okay. And after that, I'm just going through each and every user and their share like this and updating their balance sheet, as you can see over here, right? So this was updating the balance sheet of all the users. Now let's check out the strategies. So we have this split strategy interface, which has a function called as split. It takes the total amount which we will be splitting between these participants. Okay, and we would also pass the metadata. We'll understand this metadata in the percentage split strategy. So first let's look at the equal split strategy. So in the equal split strategy, we would be splitting this amount equally between all those participants, right? So for that, I am dividing this amount by the total number of participants. So this is the share for all the participants, right? Then I am iterating through all the participants and creating a new split object for each of those participants. And in this object, I would be adding that participant and their share. And finally, I am returning the list of split. So this was the equal split strategy. Coming to the percentage split strategy, firstly, let's talk about what exactly this metadata is. So if user decides to split the bill based on the percentage, then user will pass some metadata as well. So in the metadata, we have this hash map wherein the key is the user who has participated and the value is the percentage. Like 50% will be paid by user 1, 30% will be paid by user 2, and so on and so forth, right? So firstly, I'm just validating whether the total summation of all the percentage is 100 or not. If it is not 100, in that case, I'm throwing this exception, right? And if it is 100, in that case, I am iterating through each of the participants and creating the split object. So this split object would be having the participant and the share which that user will be paying. So in order to calculate the share, we are multiplying the total amount by the percentage. So the percentage of that user can be accessed using this function. And since it is percentage, I'm dividing that by 100 to get the actual value. So this is how we create the list of split. And finally, we would be returning that list. Let's check out the factory as well. So in the factory, we would be just giving the split type as the input, and accordingly we'll get the strategy object, right? Now the only class which is remaining is debt simplification service. So before checking the function, let's understand this visually. So this is the test case which we would be working on. So over here, there are two entities. The first one is the nodes, which represents the users. And the second one is the edges between those nodes. So the edges represents the transactions. And there are two types of edges. One is outgoing and another is incoming. Outgoing edge means current user has to pay someone. And incoming edge means current user will be getting from someone. Okay. So this is the original graph which has total 7 transactions. So if I turn on the simplification feature, the resultant graph would look something like this. Now, if you compare this graph with the original graph, one thing remains the same is the total number of users. And the edges which were 7 in this original graph has been reduced to 2. Further, the edge weight has also reduced. For example, here between node D and node E, there is one edge with edge weight 100. But in the resultant graph, the edge weight is 50. Also, in the original graph, there was no edge between A and C. But in the resultant graph, there is one edge between A and C. So this clearly tells us that we have to remove all these edges and again construct the edges between all these nodes, right? So let's remove all these edges. Okay. But before removing those edges, all these users will calculate their net profit or net loss. So user A will check out that total I have to pay 300 to user B and total I would be receiving 100 from user C and user D. So my net profit or net loss would be minus 200. So at the end of the day, I have to pay 200 to someone. I'm not sure whom I have to pay, but I have to pay 200. That is what I am sure. Okay. Similarly, each and every user will be knowing their net profit or net loss. If it is positive, then it is net profit. If it is negative, then it is net loss. And there might be some nodes which has no profit, no loss. So that nodes can be discarded. So let's discard that node. And now we are left with the negative values and the positive values. So let us segregate those negative and positive values and give them some name. So all the negative values would be called as sender, who would be sending the money, and all the positive values would be called as receiver, who would be receiving the money at the end of the day. So now what we'll do is we'll pick one sender at a time and we'll try to perform the transaction so that this sender can settle its debt. Okay. Now the sender A has three options. The first option is to send the money to user D, but obviously it won't be the optimal transaction, right? Because if one sender is sending the money to another sender, that won't be leading us to the minimized number of transactions, right? So that's the reason why we discard this option. The second option is to send the money to user E. But if I send the money to user E, then user A is still left with $150. So in order to get rid of $150, user A has to perform one more transaction. So the total number of transactions for user A would become 2. And after that, the total number of transactions for sender D will also become 1. So total 3 transactions would be required. But if the sender A chooses the option number 3, that is to send the money directly to user C, in that case, sender A can get rid of its debt in one transaction itself. So what we can do is we can pick each and every sender one at a time and map that sender to the highest receiver. We are doing this because if we do this, then each and every sender in one shot can try to settle the debt. Okay. If at all it is not able to settle the debt, then it will go to the next highest receiver and so on and so forth. But our first goal is to map with the highest receiver. Okay. And further, we will not pick the senders randomly. Instead, we'll pick the senders in the sorted format. For example, we'll pick the sender with minus 200 first, then we'll pick the sender with minus 50, then so on and so forth. Okay. So this is the greedy solution which would help us to minimize the transaction. So the first transaction in this case would be this, and the second transaction in this case would be this. Okay. So in this group, only 2 transactions are needed, as you can see over here. Okay. So this is the same thing which is shown over here. Right. So I hope you understood this part. Now, one important note is whatever we were learning till now was the greedy solution. The thing is, this greedy solution might fail for some of the edge cases. So if you want the accurate solution, then you can go with the backtracking or the DFS approach, right? But the drawback over there would be the time complexity. The time complexity over there is in factorial, okay? Whereas over here, it is very, very less. So let's say you went with the DFS approach, then in that case, if you exceed around 20 users, then your simplification feature will work very, very slow, right? Because the time complexity is in factorial. Whereas in the greedy solution, output may not be accurate, but the time complexity is very good. It means that even though your group has thousands of users, you would be still able to use the simplified DAT feature. Okay. So that's the reason why I went with the greedy solution compared to the backtracking. Okay. Now let's check the code for the greedy solution. So this is the debt simplification service, and this is the function which will help us to simplify the debt in a specific group. So firstly, I am getting the balance sheet of each and every user present in that group, and I am calculating the net balances of each and every user, because we have to remove the old edges and construct the new edges, right? So this is how I am removing the old edges, and I am calculating the net profit or net loss of each and every user. Then in the second step, I am segregating the positive values and the negative values. All the positive values will go into the max heap, and all the negative values will go into the mean heap. Okay. And finally, I am trying to match the sender with the receiver, and not any sender, but the minimum sender with the maximum receiver. So once I match both of them, I'm trying to update their balance sheet and the net balance. Okay. And even after performing the transaction between this sender and the receiver, if one of them is still not equals to 0, then I am again adding that particular user into the heap. Okay. So the total number of times this while loop would be running will be equals to the total number of resultant transactions. Okay, so this will basically simplify the debt in a specific group. So I hope now you have understood the entire Splitwise application. If you did, then please like the video and share this with your friends. Thanks for watching.